All right, so we've already learned how to do conditional proof, which involves assuming. And there's a second kind of proof that also involves using assumptions in what I call fantasy land. And this is called reductio ad absurdum, which, because you all took Latin in school, you will know means reduced to an absurdity. Now, this sounds super fancy, but I guarantee that you, yes you, have used this argumentative style because it's quite a common argumentative style. If you've ever been having an argument with somebody, a sibling or a friend or whatever, and they said something that you thought was stupid, and you said, oh yeah, well if that was true, then, and you went on to say something stupid, what you're doing is you're doing reductio ad absurdum, because what you're saying is, you're saying to the other person, what you're saying, other person, is stupid, and I can show that it's stupid by showing that if it were true, it would lead to absurdities. It would lead to stupid things. So because the stupid things are false, that means what you are saying must be false too. I always give this example. I don't know why, because it's not an example that really works on people from Michigan, but imagine you're a vegetarian. See, I've lost you already. But still, imagine you're a vegetarian, and imagine that a friend of yours likes to taunt you and eat big, fat, juicy Halo burgers, the best burgers, in front of you. And you get pissed off with them and you say, look, how can you do that? How can you eat cows? They're beautiful, loving animals. You know, go watch videos of cows on YouTube acting like dogs. You know, you'll fall in love. And they say, no. And your friend says this, no, I have a moral principle. It's okay to eat anything dumber than you. All right, at this point, you can employ reductio ad absurdum to attack that principle. You can say, oh yeah, well, if that were true, then you better steer clear of, well, I used to say Stephen Hawking, but he's died, hasn't he? Somebody super smart, because they can eat you. So what you're doing there is you're saying that their principle, it's okay to eat anything dumber than you, leads to the result that someone smarter than you can eat you. And if you reject that, then you have to reject the original principle as well. Okay, so it's quite a common argumentative procedure. Now, when we use it in proofs, it's a little bit more technical. I mean, it's simple, but exactly what you're doing is you're going to assume something that you want to disprove, and you're going to show that it's false by showing that after a series of steps, you can arrive at something that is necessarily false. Now, necessarily false means if you did up a truth table, there is no possibility of it ever being true. Every possible, for any possible truth value, that proposition will end up false. And the most obvious kind of necessarily false claim is a contradiction. So a contradiction is this. It's going to be something, again, I'll use shapes to represent a proposition, and that same thing with a tilde in front of it. Okay, so a contradiction is that. It's a conjunction of a proposition and the negation of that proposition. It can be P and not P, it can be Q and not Q, it can be Z and not Z, it can be A and B and not A and B. So all that matters is that you've got a conjunction, and that whatever you have on the left of it, you have that same thing on the right, only with a tilde in front of it. So the way reductio ad absurdum works is you assume what you want to disprove and show that it leads to a contradiction, any contradiction. Now, what do you want to disprove? Well, what you want to disprove is something that by disproving it proves the conclusion. And if you think for a second, what is it that if I disprove it proves the conclusion? You'll realize it's the negation of the conclusion. because if you disprove the negation of the conclusion, then you prove that the negation of the conclusion is false, which proves that the conclusion is true. So another name for reductio ad absurdum is indirect proof, because you're proving the conclusion by proving that the negation of it is false. So it's kind of a roundabout method. Why would you ever use it? Well, when it kind of gets you out of a jam. Well, let's use an example here. So this is from the textbook, page 349, question 5. So premise is if F then G then H, and you've got not F. Those are your two premises, and you're trying to prove H. Okay, if you're going to do this by reductio ad absurdum, again, you start by assuming, and what you assume is the negation of the conclusion. So you assume not H. Now, I could just write as I like to do when we do conditional proof, but we might as well indicate that what we're doing is a reductio ad absurdum. So we write ARA, which stands for assumption for reductio ad absurdum. But you're doing exactly the same thing as when you assume in conditional proof. You're just assuming something. So you can assume anything you like. It just so happens that what you want to assume is the negation of the conclusion. So now because you've assumed, again, we indent just like in conditional proof, and this is all in fantasy land, and all the same rules apply as with conditional proof. So now, that actually is immediately useful, because if we just had these two, I'm sure we could prove it without assuming at all. But what reductio ad absurdum does is it makes proofs easier. So now that we've got not H, we can immediately do, well, what can we do with not H and the first line? That's right, I hope you said what I'm about to say. You can do modus tollens, denying the consequent. So that would be MT for modus tollens 1, 3. Now remember, the weird thing about reductio ad absurdum, which makes it different from both conditional proof and regular old proof, is that you don't have a specific target in mind. You've got to get a contradiction, but any contradiction will do. Now contrast that with regular proof. With regular proof, the only thing that counts as success is if you get the conclusion. With conditional proof, once you've assumed the antecedent, you have to get the consequent. Nothing else will do. Whereas with this one, you don't even know what you're shooting for. It could be H and not H. Now notice you don't have H here. That's just telling you what the conclusion is. But you've got not H, obviously. Or it could be F and not F. Or it could be G and not G. Or it could be if F then G and not if F then G. So any one of those will count as success. So as a result, unlike with regular proof, you're not really using the work backwards from the conclusion method. You don't say, well, I've got to have this. How do I get that? Well, to get that, I need this. And how do I get that? To get that, I need this. Remember how we work backwards from the conclusion. You're not going to do that with reductio ad absurdum because you don't know what it is you're trying to get. You're just trying to get some contradiction. So as a result, you tend to use what I call stumbling forward blindly. You're just trying stuff out, seeing what you can do with stuff. So with this one, whenever I see the negation of a conditional, I always think implication, and I happen to know that if you do implication to this, it becomes F and not G. Why is that? Well, what this is saying is that the negation of a conditional is true, which means that the conditional is false. What is the only circumstance in which a conditional is false? When the antecedent F is true and the consequent, in this case G, is false. So F and not G is what you get. And you can probably see pretty quickly the easiest contradiction to get. I can simplify F. And now, 9 times out of 10, or probably 99 times out of 100, your last indented line will be a conjunction. Because what you tend to do to construct your contradiction is on one line you get the proposition, and on the other line, and then on another line you get the negation of it, and then you stick them together to make the contradiction. So we have F and not F by a conjunction of line 6, which had F on it, and 2, which had not F. Okay, so once you get your contradiction, you're done in Fantasyland, and you go out to the real world, and you've proved, what am I saying? This is 8. What you've proved is whatever it is you negated on the first line. So because your first indented line is not H, you have proved H by reductio ad absurdum. So this stands for assumption reductio ad absurdum, whereas this is just reductio ad absurdum, all the indented lines, 3 through 7. And that's it. That's how you do reductio ad absurdum. Again, it might seem a little weird because you don't use what's on the last line. What's on the last line is a contradiction, but you don't refer to it once you come out. So it's not like conditional proof, where you come out of conditional proof, you refer to the last line as the antecedent, and the first line as the antecedent and the last line as the consequent. Whereas here, you just say that you've proved whatever it is you denied on the first line. Now, like conditional proof, reductio ad absurdum you can use in the middle of other proofs. You can say, okay, in order to prove this, I need F. I don't have F. Let's just hop into Fantasyland, assume not F, and then get F, and then use F to finish the proof. So you can use it in the middle of things. You can combine reductio ad absurdum and conditional proof if you're getting super flashy. But you probably won't need to do that for the stuff that we're doing. All right, let me do one more example just as, well, as an example. Okay, so let's do the next one. In the textbook, page 349, these are exercise 10.5b. Let's do question 6. Okay, that goes not J, then K or L, J, then M, not K and not L, and then the conclusion is M. So this is premise, 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 slash conclusion. All right. Now, how do I start? Again, I start by assuming the negation of the conclusion. So, not M, by assumption, reductio ad absurdum. And again, I don't know what contradiction I'm going to get. It can be J and not J, it could be K and not K, L and not L, it could be K or L and not K or L. We'll just see where it takes us. But I can immediately use this not M again to do modus tollens with lines 2 and 4, and that's going to give me not J. And again, I'm just stumbling forward blindly. Hey, I can use that not J here as modus ponens 1, 5, and that's going to give me K or L. And actually, you can see that I've got two options. They will both take the same amount of time. So I could do not K, simplification, line 3, and then I'm going to do disjunctive syllogism with those two lines. It's K or L and it's not K, so it is L by disjunctive syllogism 6, 7. And then I've got not L up there, so I'm going to simplify that. And you can see what my contradiction is going to be. It's going to be L and not L. What am I doing? L and not L by conjunction 8, 9. And then, of course, once I've got my contradiction, I go back to the real world, and whatever it is I negated on line 4, I've proved by reductio ad absurdum 4 through 10. Okay? Now, I could have gone a different way when I reached this point. So I could have gone, instead of simplifying not K as I did, I could simplify not L, and then I could have used that to get K by disjunctive syllogism 6, 7, and then I could have simplified not K from line 3, and then my contradiction would have been K and not K by conjunction 8, 9. So that's a different contradiction. I can either use L and not L, or I can use K and not K. Whatever contradiction, it doesn't matter. Whatever one you get to first, you can probably get others. I could probably mess around and work out another contradiction I could have got. Yeah, in fact, I'm going to do that. I'm going to do that so this proves m by reductio ad absurdum, 4 through 10. Okay, so that's two possible contradictions. I'm going to try for another one. So, I'm going to run out of paper. I'm doing it this way. Okay, I'm going to try something a little cleverer. I'm going to do De Morgan's law to line 3. Now, if I do De Morgan's law to line 3, you're used to De Morgan's law going the other way, when you have a negation outside of parentheses and you sort of distribute the negation. Whereas here, I'm going to end up with that. I'm going to end up with that. Now, I'm going to do modus tollens with lines 1 and 5. And I'm going to take the extra step that you don't have to do of just adding the tilde. So that's going to give me not j, and then I'm going to get rid of those double negations by the tidy up rule, which gives me j, double negation line 6. Now I can get m by modus ponens 2, 7. And you can see I've got m and not m is my conjunction of 8 and 4. And that's actually a slightly quicker way, because that gets me my contradiction in one fewer step. So that's m by reductio ad absurdum 4 through 9. So, 3 possibilities: L and not L, K and not K, M and not M. Any one of those works equally well. That's reductio ad absurdum.